lesson, we'll continue our discussion of arthrology by taking a look at synovial joints. In a previous lesson, we had discussed that there are three types of joints. There are fibrous joints, there are cartilaginous joints, and in this lesson, we're going to take a look at synovial joints. Now, synovial joints actually have a space between the two bones, and the capsule that surrounds the joint is lined by a membrane known as the synovial membrane. So these line the synovial joint cavities. Now when we move our joints, that stimulates the production of a fluid known as synovial fluid. And this is going to lubricate the joint. Now, if we were to look at this under the microscope, we would actually see that it is not a continuous layer of epithelial cells. It's discontinuous, and I'll show you what I mean by that in a second. So here's an example of a synovial joint. What we have up here is a bone up on top, right? A superior bone here. Now, this is hyaline cartilage. This is known as articular cartilage. Then here's the bone below. Same thing. Here's the hyaline cartilage at the end of the bones. But notice there's a space here. These two bones don't touch, right? We could actually see that space on an x-ray. Now, the synovial joints have a capsule around the entire joint. So this gray out here would be what we call the joint capsule. It surrounds the whole joint, which is seeing part of it. Here's a blow up of it. So out here, this is going to be the joint capsule. All of this in gray out over here. Underneath the capsule, we have a little bit of connective tissue. This yellow over here, this is areolar connective tissue. All of this is a little bit of fat cells in there. Here's a blood vessel. But look at this red group of cells here that come down. Notice they're not continuous. There's a little space here. Here's some more cells, space, some more cells. This is the synovial membrane, right? It consists of this epithelium and the areolar connective tissue, right? That's the actual membrane. So this red line here you can see is the synovial membrane on the inside of the joint capsule. And as I said before, as we move and do things, this synovial membrane will produce the fluid that goes in here, and that lubricates the joint, nourishes the cartilage here. All right, so that's the anatomy of the synovial joint. Now, there are 6 types of synovial joints I'd like to go over with you. The first one is known as a gliding joint. What's unique about these is the articulating surfaces, when that means the joint surfaces, are flat. So examples would be the intercarpal joints. These are the 8 carpal bones, right? The carpal bones, or the joints between the carpal bones. So you can see over here we have some carpal bones, and if you notice, the joint surface here is flat. The joint surface here is flat. So this would be a gliding joint right inside there. We can see over here too. Right, so these are considered gliding joints. Same thing, intertarsal. These were the 7 tarsal bones, so between our tarsal bones. The sternoclavicular joint, where the sternum meets the clavicle, would be also a gliding joint. And if you notice here, this is just kind of a description of how the gliding joint would move. This top bone here would just like slide back and forth like this. It could also slide side to side. So that's the type of movement we see in a gliding joint. Right, here's the sternoclavicular joint. So this is the manubrium. This is called the clavicular notch right there. And then here's the sternal end of the clavicle. So this is relatively flat. This is relatively flat here, and you can see the clavicle can slide forward, backwards, a little bit in and out like that. Okay, so that's our gliding joint. The second one's pretty easy. This is a hinge joint, right? If you think about a door, you can open and close your door. That's about it, right? A door to your room, let's say, you can open it, you can close it. You can open it, you can close it. You really can't do much with it. So this is the same type of thing we're going to see with a hinge joint. This is where one surface is convex and the other one is concave. Right? Some easy examples would be the elbow. So we could see here, this is the condyle of the elbow right here. This would be the capitulum. That's going to meet the radius. And then this would be the trochlea. And that's going to meet the trochlear notch of the ulna. When these two fit on here, we're able to bend the elbow, right? Close the elbow, open the elbow. So we can see an example over here of simulating the elbow joint, right? This would be like the humerus, this would be the radius and the ulna, and then we could move the hinge, the hinge, open the door, close the door, right? Open the door, close the door. We can't turn the door, we can't, tilt it or anything like that. It's just open the door and close the door. Another example would be the knee joint as well as the ankle joint. Okay, so that's the second type. The third type is known as a pivot joint. This is also pretty easy. This is just turning. This is where the bone is allowed to turn. So here the rounded surface of one bone fits into the shallow depression of another bone. So we can see over here, a good example is the radio-ulnar joint. There's two of them, the proximal radio-ulnar joint above here, and then if you look down here, the distal. So what we have here is the head of the radius. This would be the round part. And then this would be the radial notch on the ulna. So now when we, pronate and supinate our forearm, we pronate and supinate our forearm, the radial head pivots in the radial notch. The same thing happens down over here, right? The ulnar notch will pivot on the ulnar head. Another good example that we studied is the joint between the atlas and the axis, right? This is known as the atlanto-axial joint. So we can see here, this is the dens, this is the anterior arch right here, and now the anterior arch will pivot on the dens as we rotate our head to the left, as we rotate our head to the right. So that was the second example I put over here, the atlanto-axial joint. Right, so you can see here again, just as showing the direction of the movement from a diagram. Here's the peg, here's the round part, and then again, this just kind of pivots. You could rotate to the left, you could rotate to the right, rotate to the left, rotate to the right. We can't really do anything else. It's just one plane of movement, which is turning. Okay. The fourth joint is known as an ellipsoid joint. So this one's a little more difficult to understand. Think of elliptical cavity as being an oval that you kind of stretch out, that you elongate. I put that over here. Think of an elliptical cavity as an elongated oval. So the oval shaped convexity surface articulates with a shallow elliptical cavity. Let me show you the radiocarpal joint real quick. So if we kind of make an imaginary arch right here from the scaphoid bone, and we just kind of follow my cursor like this all the way around to the lunate this way. So this would be the convexity. And then inside the wrist here and the ulnar, there's it's concave, there's a concavity, but it's an oval that has been stretched out, right? So it's kind of an elongated oval. So the scaphoid and the lunate fit perfectly into that elliptical cavity here. And this would be the joint between the radius and carpal bones. Another joint is the metacarpophalangeal joint. That's between your metacarpals and your phalanges. Now, these joints allow for movement in two planes. You can, if you took your wrist, you could kind of bend your wrist forward and backward. That would be flexion and extension. And then you could also go side to side, which would be abduction and adduction. So they do allow for two planes of motion. Okay. So that's our elliptical joint. The next one is known as a saddle joint. So here, the saddle shape of one bone articulates into the saddle shape of another bone. So it's a little bit hard to see on this picture, but this kind of dips in a little bit like a saddle. The trapezium also has a little bit of a saddle shape to it, and they interlock. The best example of this is the first metacarpal joint. That's the articulation between the first metacarpal here and the first carpal bone here, which is the trapezium. So the trapezium meets the metacarpal bone of the thumb right over here. And this is the saddle joint. This is the only one in the body. This also allows for two planes of movement. If you try to move your thumb, you can flex your thumb, you can extend your thumb, and then you can also abduct your thumb and adduct your thumb. Similar to what we saw with the ellipsoid joint, we could do two planes of movement: flexion and extension, abduction and adduction. right? Same thing with the saddle joint. Okay, the last one is an easy one. This is known as the ball and socket joint. We'll take a look at the shoulder joint as a great example and the femur. I have the picture here is going to be on the shoulder joint. So here the round head articulates with a cup. So we can see here, here's the head of the humerus, and that's going to articulate with the glenoid cavity or the glenoid fossa right there. And this allows for 3 planes of movement. This gives us a lot of movement. We can flex and extend our humerus. We can bring it out, abduction and adduction, and then we can also rotate the humerus. And we would see the same thing on the femur. The femur would be the femoral head in the acetabulum. And that, again, the same thing with the femur. We can flex the femur, we can extend the femur, and we can rotate the femur medial and laterally. So that concludes this lesson on synovial joints, what a synovial joint is, and what types of joints we have. And again, you can see these synovial joints are the ones that are the most common in the body, and they do provide the most amount of motion compared to a fibrous joint or a cartilaginous joint.